We have a new module, mist maker. Open the module. This module I bought from online store. We have foam, sort of a foam, and this is the module kit. There's a lot of Chinese letterings. And then we have this board, and it is micro USB with push button and SMD components, also with the connector and coil. Is this a coil? Inductor, and we have now the mist maker device. What we call this? This is the going to assemble it here, and then this one. Okay, no good. And then where is the mist? Oh, here. Oh. Okay, we're going to connect it into the board. They're going to supply it with 5 volts. What is this? Why is it there is a washer? Or what? Here? Let us get the supply. 5 volts. This is now the power bank, 5 volts. We're going to use the supply with USB cable. 5 volts micro USB to be connected here. And then when we press the button, it will switch on the board. But there is a washer and the nuts. What is the use of these two metals? And there is a problem because we're going to use the water to make the mister. Can you hear the sound? There's an oscillation or sound. So you can hear the high frequency sound. Can you hear that? Whenever I press the button for turning on the module. So this is an oscillator. The problem is we're going to dip or submerge or soak it into the water so that it can absorb the water to make the mist, because we're going to use this as a mist maker. Let us first disassemble this thing, because our wire is, we're going to short the wire when we're going to dip it into the water. So we need to change the position of the wire. How to do that? By again disassembling. The wire should be here at the edge or into the side, this wire, so that to avoid short circuiting the module. Let us disconnect. It's very hard. Okay, where is the module? So let us first test without short-circuiting this ultrasonic mist maker, the wire. We're going to dip that into the water. Let us do that. And then powering 5 volts micro USB. Avoid short-circuiting the wire. Just dip the mist maker module on. See? We can see the mist. So the circuit is working. It converts the electric current into water vapor. Vibration, sound, then into water vapor. That's why it created this smoke. So we don't need to short-circuiting the circuit, the wire, because our board will damage if we're going to dip the wire into the water. So this is sometimes called atomizer, humidifier, or mist maker. Always use in our house with flavor. You can see that the smoke coming from the mist maker module, ultrasonic mist maker. So it works. Kill the circuit. Let us now use this some kind of what's this, cigarette filter? Looks like a cigarette filter. We're going to dip that. It will absorb the water. Then we're going to put that here. You can see that. Okay. Oh. Okay. The smoke is coming out. So he created the mist. So it is working with the use of this look like a cigarette filter. Let us again connect this thing, this holder. Here we have the figure 1 mist maker module. So this is the main board, and main board, it has a micro USB for power supply. So we are using 5 volts into the USB, micro USB port. This is a power bank, BS voltage supply. That is the supply of the board of this mist maker. And then on board this mist maker, we have the switch. So this switch is becomes a toggle switch, or it will turn on and off by pressing this switch. There is a latching. It becomes a latch switch. Whenever we press it, it will turn on the module. And then the output. This is the output, and we have the ceramic disc piezo type mist maker. This is the output, and it emits, or this is where the smoke. So there is smoke. It can produce the smoke using this disc, or this piezo type disc. So when we attach the power supply to the module and then pressing the switch, we now have the mist maker module. It emits, or it can produce a smoke. Why is it that it produces a smoke, or it produces smoke? Because this board acts as an oscillator, producing an AC voltage. So AC voltage into the output. So there is an AC voltage, AC, into the output of this piezo disc. And that voltage is being converted into water vapor, or smoke, so, or a mist. So we have now this smoke coming from this disc. We use this disc. Remember, we use this round with filter disc. And the function of the board is, it is an oscillator. If this is an oscillator, it can oscillate a certain frequency. So we can now measure the frequency at the output. So we can connect if this is the positive one and then the negative one to we're going to connect here to measure the frequency to the oscilloscope. So we're using oscilloscope, the positive and then the negative of the output, to measure the frequency. What is the frequency of oscillation produced by this board? So remember that an oscillation is a continuous wave, just like this one, continuous wave. This is an oscillator, a continuous and constant waveform is produced. That is the oscillator, or the oscillation. Let us see the frequency produced by this module. So we can verify what is the frequency used in this module to make this mist maker. We have now the circuit. Again, we have the circuit, and now the output. We're going to measure the frequency using the breadboard extension for the wirings. This is the probe of the oscilloscope, now connected to the output, or to the mister, or to the disc. Let us now powering on this power bank. Okay, it is on. pressing the switch. Again, we are producing mister or sometimes called humidifier or atomizer, ionizer. We can now see the output frequency into our cable to the oscilloscope. Let us take a closer look at the oscilloscope. So you can see the oscilloscope is smoking oscilloscope. Let us this is the waveform produced. That is the oscillation or oscillator, because it produces, or it has a continuous waveform. Continuous waveform has been produced by the circuit, and it has a positive voltage and a negative voltage. The negative voltage is not accurate as a sine wave, but still this is considered as AC voltage, because we have positive voltage, negative voltage, and then at the middle we have the DC biasing, or the DC point, positive, negative. The negative voltage is something look like irregular. So here, let us see the measurement. Voltage RMS, or the AC voltage, is 23.31 volts. Frequency is 108.4 kilohertz. So it is 108.4 kilohertz. That is F. And then M, that is MI, that is the minimum voltage, negative 25.39 volts. That is below this DC. The DC point is the blue line. That is the minimum. And the voltage average of voltage DC is 609 millivolt. Then we have this total voltage. Okay, we have this total voltage, and then period, that is equivalent to one cycle, one period during the positive and negative output of the wave. That is considered as one cycle or period in digital. Voltage peak to peak, 70.31 volts. From this point to up to this point. Maximum is 44.92 volts. And our, what is this? Okay. We're using 50 volts per division. But if we're going to use 20 volts, we have this waveform, 50 volts per division. That is a smaller one. And this one, 50 volts, 20 volts per division. So, our concern is what is the frequency? It is 108.4 kilohertz. So that is a continuous waveform produced, alternating voltage, positive and negative voltage. And this is the AC waveform generated by the mist maker, figure 4. This is the oscillation, positive voltage, and then the negative voltage, positive, negative, and so on. So vertical voltage with respect to time, that is the waveform. So here is the positive voltage to the negative voltage. We have voltage peak to peak. So this is alternating AC voltage, current voltage, or voltage, because we have positive and negative voltage generated by the maker. And this maker, I have a reverse engineering of the maker. This is the same as the module. So we have the 5 volts micro USB microcontroller. That is the one that is generating the pulse, the microcontroller, and then the switch, the inductor, transformer, inductor, the output, wherein we connect this the disc to the output. Also with the MOSFET, transistor, and other SMD devices, surface mounted device. So this one is this. After reverse engineering or tracing the connection of each individual components, we can now arrive to the schematic diagram of maker. In this diagram, we have the 5 volt supply. This is the 5 volt supply, and then we have 2 capacitor in parallel, the coupling or coupling capacitor, just to stabilize the line or the circuit, because this circuit and this microcontroller, especially this microcontroller, is capable of producing AC waveform into the output, wherein we measure the output from the disc. This is the disc or the piezo, or the one that generates smoke, this one. And then this is the coil. So by injecting this is the one producing the PWM, but this PWM is an AC. So injecting a positive and then the negative, positive voltage, negative voltage. So you can see here we have the capacitor that is capable of filtering the signal or the waveform generated by the microcontroller, that is with positive and negative voltage. So this capacitor, we can able to pass the positive and negative voltage to the capacitor, and then producing a voltage across 510 ohms, or while we're injecting or generating a voltage at the gate of the MOSFET. And because of that, we generate a voltage, produce a voltage at the gate. It is now, the current will now flow from drain to source. With respect to this coil, small coil, and a large coil, so there is a stepping up of a voltage. Okay, that's why we measure a voltage here at the piezo in our oscilloscope around there's a higher voltage, which is higher voltage than the 5-volt supply. We measure from the piezo. So when injecting a pulse here, causing to produce a voltage here, a positive and negative voltage, the current will flow from drain to source, then source to drain, drain to source, source to drain, drain to source, source to drain. So it will now capable of producing a continuous oscillation of AC voltage. This one. So we can see the oscilloscope. We have this waveform. This is a transistor or MOSFET. So this one is the indicator with the LED and the series resistor. So every time we press the switch, since this is microcontroller, this switch will latch, pulling down the current to the ground, pulling down the microcontroller to the ground, causing it to act as a latch switch. When we press it, it will turn on the signal. The signal now generate from the microcontroller will injecting the signal to the gate. Then while injecting that signal, it will now capable of producing this output. So we need the voltage from gate to source in order to pass the current from drain to source. So we need the voltage GS to pass the current from drain to source, and back and forth, because we are having a positive voltage and negative voltage develop across the output side of this MOSFET, output voltage or output of this MOSFET. With the help of this ceramic piezo disc, we are capable of producing 108.4 kilohertz frequency while using this system. Every time we press the button, it will turn on. Press it again, it will turn off. Okay, you have the supply for the IC and then the ground for the IC, and this one is the output of the IC. Injecting the output to the MOSFET. While MOSFET, we have the MOSFET. This is the driver, serve as a driver of the ceramic disc and the inductor that will make or capable of producing this AC waveform with positive voltage and negative voltage. And why is it that we produce a smoke? Because of the converting this current into bubbles, and then bubbles into the water vapor. Okay, and then this water vapor will become evaporates or will now serve as a humidifier or a mist maker.